So, hi everybody. Thanks a lot for coming. Sorry, and I'm not allowed to go there. So, today we want to show you something about WebAssembly on Kubernetes, and we want to go into how we can use WebAssembly instead of classical Docker, open containerization native images to run your workload quicker, coming up, and so on. Who of you runs already Kubernetes? Okay, great. That's perfect. Otherwise, we would need some additional minutes for intro. And who already used WebAssembly? Okay, some. Great. Perfect. So, today we have Linus Basic. He's head of engineering at Karoo. And myself, Fabrizio Lazzaretti, working at Wavestone as a managing consultant and also a CNCF ambassador. And today we want to show you where we went a little bit of 5 years. We just found out we already are working a little bit on how can we do event-driven architecture with Rust and some new types of working with that. Yeah. So, how do we want to start? We want to look at one use case. It's not a real use case, but we want to go with you through that one in this presentation. And we want to show you how there we can use these technologies. Our use case is we have some emails that we get. It's some support use cases. There we have them. We need to channel them through to our compute. And then we will need to prioritize them for different use cases. So we have maybe a VIP support. We have some support that is specialized on some other things. And maybe also some third support for not so important stuff. So there we need some triage. So we need some compute. And we have some emails at the front. And now our problem is we are really good. Or maybe our software is really bad. And now we have many support cases. So we need to scale when we get a lot of mails, and we should do that fast. And we are not able to predict because it's really coming from the outside, from the edge, right? And so we want now to look at this example with something already in mind. We already use Kubernetes, what you already know and use as well. And we want now to look on how on Kubernetes we can now here optimize things to dynamically scale and have time-sensitive scaling. So when we start with something like that, right, we have first our pod, we have some fixed scale, maybe one instance. This will not work long if we have a lot of things coming up. So what will we do? First, the simplest thing is we go to horizontal pod auto-scaling based on CPU RAM, right? That's the first thing. It's a really simple thing. But the problem here is we always need to wait. So we will only find out after some time that our CPU is on full load, and we probably should do more. Otherwise, if we just say, we have some CPU spikes, we go up, we will scale way too fast. So we can use some custom auto-scaling metrics. And there, the world is really open. We can do everything, but it's a lot of work. And there we have KEDA, one CNCF project that really helps there. They have some scaling policies. For example, we can use, if we now use before for the channel Kafka, we can go on that, or we can also use a simple SQS service and also scale on that on the length of a queue. And so we can really just say, hey, something came into the queue. Now already let's scale up because we know there's a lot in the queue. And also scale down if the queue gets fewer entries, new ones, even though our CPU is still on 100%. And then we can even go one step further. If we say we want to do a little bit more than just auto-scaling, we can use a full framework like Knative, also a CNCF open source project. Then there is a little bit more opinionated about what we do. And there we can really then dive deep a little bit afterwards and say, hey, this can now really help us with the whole journey. But this is really an opinionated product. And these are the two things that we want to look at, how we can use KEDA, Knative, together with WebAssembly. So now first, let's look at how these Knative and KEDA work together. So as said before, let's imagine we have Kafka in front. We have a topic there where this email information come in that we have some emails. Now we can use KEDA, which listens to Kafka and says, hey, we know we have a consumer group, right? We just do really the normal implementation of Kubernetes and our resource that says, now just grab the newest messages, right? We have some consumer group normally, or on a queue we have a specific queue for these readers. And then KDA can just also, with the same credentials, read these things and say, okay, I know there are a lot coming in, now let's scale up. Or there are not many more in, now let's scale down. Now that we have scaling, how do we make it faster? And here Linus will get over with the same microphone.
Thank you very much. So yeah, as Fabrizio said, now we have the dynamic scaling checked. Now how we can make it scale like faster. And as you may remember from the title of our talk, of course the answer is WebAssembly. So before we start looking into WebAssembly, a short disclaimer. So what you saw until now is really production-ready stuff. So KDA is like a graduated project from CNCF. Like it's widely used out there in production. But yeah, WebAssembly is also quite like mature technology, but in combination with Kubernetes and server side, it's like a little bit on the sharp edge. So yeah, we also observed now over the years it's like really slowly progressing, but there is potential. So let's have a look. How does WebAssembly work on Kubernetes? So it works very similar to your normal container-based workload. So yeah, you push it to a container registry, and then there's like you schedule some work to be done. The kubelet will pick up the work and will hand it over down to a CRI runtime, and then there's a little bit of a split between containers and WebAssembly. So it's still will download it from the registry and then hand it over to the OCI runtime. And yeah, there we have on the one hand have the container ones, which set up like the C groups and all the stuff. And on the other hand, we have the WebAssembly runtime. Usually we can use the same CRI runtime on top and then just have like a skim which then handles the translation or the differences between containers and WebAssembly. And yeah, with the runtime, it's then running like a sandbox. But yeah, let's have a look at WebAssembly. So what's WebAssembly? So at its core, WebAssembly is like a platform-independent byte format. There are many languages which compile down to WebAssembly, and there, like over the years now, more and more languages start to support it. There are some interpreted languages which support WebAssembly, but yeah, these are like they compile down like the interpreter, and then you like run the interpreter in WebAssembly. You don't get all the advantages of WebAssembly if you do that, but it's possible. So you have the languages to compile down. Then one important building block is WASI. This is the WebAssembly System Interface. It's like a standard which defines some system interfaces like I/O access, file system access, clocks, like database stuff, and so on. It's just the interface, and that again is implemented by the WASM runtimes. So the WASM runtimes take over like the heavy lifting. There's, for example, also an interface for like HTTP request to receiver. So the runtime will like parse the request, maybe do some authentication, and just hand over like really the request itself, and the main work is done with the runtime. And yeah, we are at the WASM runtime. It's like a virtual machine which takes the WebAssembly bytecode and then interprets it on your specific platform. Maybe that sounds a little bit familiar, and yeah, it's really like the next evolution of the approach of what Java did for us. And yeah, from background, it's like really born in the web. So as you maybe know, it's initially built for the browser to run like low-level code safely into the browser. So they do a lot of things to make it safer and like differentiate from Java applets, which are notoriously like dangerous to run in the browser. And also they did something on the structure which makes it easy to start interpreting the WebAssembly while it's downloading. So yeah, that's a good thing to go over. Then to the advantages. So we have wanted to highlight like 3 advantages for WebAssembly over the containers. So on the one hand, we have tiny images, because you're really just shipping the code, your business logic. Classically with a container, you also bring a lot of additional things which like take time to download. Then the other thing also mentioned is like the bytecode, so it's very fast to be interpreted, so while downloading, as I mentioned before. And it's platform independent, so you have like a heterogeneous fleet of servers which can run your stuff. And then the third advantage we see is the WebAssembly System Interface. So it comes with a lot of battery included, so you don't even have to include that in your code, so the runtime will provide it for you. One disclaimer for the WebAssembly interface. It's like very early on, so we're currently at version 0.2, and they promised the 0.3 for next month. But we'll see, and then the 1.0 will come at some point. Good. Then let's have a look at the whole theory in practice.
So now we go back to our example from the beginning, where we now get our email, we put them on Kafka, then we have Knative now with Kda under the hood, which takes these events. So before, we said Kda just checks the consumer leg. Now Kda will do that, but it's really just part now of the demo where we also use Knative. Knative has the benefit, so it's really one opinionated system for everything. The drawback is you will not put that on your system probably when you already have something on, because it really says everything how you should do it. It starts with certification management, then on how you integrate, also a little bit of namespacing and so on. So it's really a full-fledged thing. But the great thing for a demo also is, and also new system, it's really one thing that also everything great plugs together. And so here we now have Knative in between. So we really just need to say to Knative, hey, we want to consume from here. And there on the other side, we have a small function which will execute something with that. And they will now read from Kafka, they will automatically scale with Kda under the hood, and they will forward it to HTTP. So one thing also that is really great to switching to HTTP, we said WASM is on the start with WASI, so there's currently no implementation to use Kafka directly, so it's really great to go there over HTTP, and Knative will handle that all for us. So, and now we have a demo, which also loads. That's great. So what we will show you now is this example from before. Here you will see on the left top all the pods on the cluster that we have. And we really run it just on a MacBook, so nothing powerful. And you will see we will go over hundreds of containers in really quick time. On the bottom, we will just at the beginning with a small producer simulate a lot of emails coming into the system and pushing them to Kafka, these events. And on the right, you see a UI for Kafka, where we see our consumer group, where we see that first we will get a lot of emails, and then we will process them one by one. And I hope the play button works. So, and now we just generate 1,000 emails. And you will now see we have the email consumer coming up. It's one, and we set at the rule to Kda, hey, just double it if there's still something on the queue. It helps for the demo. Otherwise, it will just be full of containers, right? But something that you now really see is when new containers are coming up, they will be instantly from container created just in running almost, even on a small computer, because that's now really the fast thing, right? These WASM images are 0.4 megabyte each, compared to the same logic that we also implemented with a container and a Alpine image, and it's still 4 megabytes. So factor 10 with no additional libraries and so on, which really shows we're faster, we're smaller, and there is no startup time. So this really helps there. And you see now they are all coming up and we're going faster down. And also one thing that is, if you're particularly now going to Kafka, really helpful if you use Knative, is that we only have one consumer here, right? This is because now Knative is using that, and just that, Kafka in consumer group, you add additional things. First, you have the limitation that you will never get more parallel consumers than you have partition. And on the other side, negotiating that protocol with getting more consumers also takes time, which we don't have if we have something like Knative in between. And so like that, we went now through the consumer lag. It's almost with 0. So we have set our dummy code to use 1 minute to process an email. So that's why it still takes some time. But we see that we're now almost at 0. And I think, yeah, now it's done. So that's our small demo that really shows we can do something like that really quickly and really scale fast when we use WebAssembly for event-driven architecture use cases where we need to process something. Now, that's like our demo. So where is it really used? Here we want shortly to show three well-used projects that now use WASM. So one is the Dapper thing. That's a big project on CNCF that now uses WASM for HTTP handlers. So if you want to do there some custom logic, you can just add some plugins with WASM, which is really great, right? You don't need to compile them into the REST. You can just plug them to it, and they can process something. The same with Istio. Also, they are using it in their plugin architecture in production to have a proxy WASM sandbox. So again, you can just have your logic in the application language you want and just add it to this project without any need for compilation, which is really great. And the third thing, again, a plugin use case. You see where currently in production most open source projects see the benefit. It's really about plugins. And not needing to recompile or anything. And the third thing is Helm. And here it's not just a plugin that you don't need to recompile and you can use your own language, but the third benefit there is you don't need to trust the author, right? So Helm is a package manager, and there these plugins are on your machine. So you can now download it. They have assigning algorithms, but you still don't need really a lot of trust because they are fully sandboxed. You don't need a cluster or something. They will just run it in this WASM. It will only be interpreted, the code, so it's a little bit more safe to run it on your system like these third-party plugins. And how does it now work if you want to use WASM for plugins, which I think is a really great use case? So here is a little bit really simplified how Dapper is using it. So on the right side, you see how you can implement it on the host. So this is like a really simple thing. Vatzero is a really simple runtime for it that you can just use in Go. And you really just say, hey, I want a new runtime for WebAssembly. You need then to instantiate it. And then you can really just call a method. And this will then be passed there. It will be executed, and you get the result. And on the other side, we see now how you can implement something. This is with TinyGo. They also have a booth somewhere, so if you want to know more about TinyGo, it's also the right conference for that. And here's just a really small HTTP function that is a little bit closer, but too complicated to show on the right side. And you see, you just have one function, and you can do small code, return, and that's it. So I think it's a really good thing if you want to use it for plugin, and also it adds some safety and just decouples the programming languages.
Good. So what's the approach if you want to get started with WASM? So there's a little bit of reading to do. So there's the WASM component model. Probably you should be familiar with it before you start. And then there is also the system interfaces. And if you understand them, then it's quite easy. We recommend to start with Rust because their ecosystem is really great. But yeah, nowadays, like you saw, TinyGo, and there are a lot of other languages which start to really support WASM as a compile target. And yeah, when you have your Hello World app and you have like created the WebAssembly binary, then you need to decide what runtime you want to use. There's a big list, or like a lot of projects. Some of them like are really strictly implementing just the WASI interface. Some have some proprietary interfaces that they implement as well to do additional things that the standard interface doesn't cover. And then if you really want to go the rabbit hole down with Kubernetes, yeah, you really need to look into the run times, because like the most common ones like runwasi doesn't support WASM directly, but there are some, for example, crun or runwasi that support already today WebAssembly on as a container type on Kubernetes. Good. Then yeah, that's it. Let's have some questions.
Maybe why do we have a QR code? If you want the slides, you find them there. And also to point out, if you're still a couple days longer here, on Monday starts OTel Unplugged. If you want more about OpenTelemetry, which also is heavily often used with Kubernetes, that's a nice event, I heard.